Look at a map of the United States and your eye goes to the edges. The coasts hold the big cities, the money, the drama. The middle looks like the part you drive across to get somewhere else. Now find Oklahoma. A tidy rectangle with a handle, sitting dead center in that empty middle. Except this quiet-looking rectangle is where the sky comes apart. This is the ground under the widest tornado ever measured on Earth. It's where the warm, wet half of America and the hot, dry half of America crash into each other every spring, and the collision has nowhere to go but up. So why did a state that looks this empty on a map become the capital of the most dangerous storms in America? And why is that title starting to slip away? Start with the thing that everyone gets wrong. Oklahoma isn't flat. The straight-line borders trick you into thinking the land inside them is uniform. It isn't, and the difference runs east to west like someone drew a line. The eastern edge is green, timbered hills, real rivers, the tail end of forests that stretch back toward Arkansas. It gets close to 50 inches of rain a year in the far southeast, wetter than a lot of the deep south. Then drive west, and the water drains out of the landscape mile by mile. The trees thin out, the grass shortens. By the time you hit the panhandle, you're in high, dry plains getting under 20 inches of rain a year. There's a spot out there called Little Sahara that's nothing but sand dunes. The far western corner rises into Black Mesa, closer in spirit to New Mexico than to anything you'd call the South. One state, two completely different climates, sitting side by side. And that's the setup that matters. Because when the wet half and the dry half share a border this sharp, the border doesn't stay on the ground. It goes into the air above it. Now, you already know Oklahoma has bad weather. Everybody does. This is Tornado Alley. The branding is even on t-shirts. Oklahoma City has been hit more than 100 times. The town of Moore has been torn up by violent tornadoes again and again, one of them killing 24 people in 2013. Every spring, the state goes into a familiar rhythm. Watch the sky, watch the radar, know where the shelter is. And there's oil under all of it. Oklahoma sits on the Anadarko Basin, one of the richest energy zones in the country. The state was built on boomtown money. The Capitol building had a working oil well right on the lawn. So the easy version of this story is just bad storms, good oil, roll the credits. But naming the tornadoes and naming the oil only tells you what comes out of Oklahoma. It doesn't tell you why. Plenty of places get storms. Plenty of places have oil. What it doesn't explain is why the violence stacks up on this exact rectangle. Or why empty and extreme turn out to be the same fact, not two different ones. For that, you have to look at what's actually colliding. Here's the machine. From the south, warm, wet air comes pumping up off the Gulf. Heavy, humid, unstable. From the west, hot, dry air slides down off the high plains and the deserts beyond them. And where those two air masses meet, they form a boundary the forecasters call the Dryline. It's not a temperature line, like a cold front. It's a moisture line. Soaking Gulf air on one side, bone-dry desert air on the other, pressed right up against each other. And that boundary sets up over the southern plains, right through Oklahoma, over and over in spring. The dry air wedges underneath and pushes the wet air upward. That rising wet air is the fuel. Add a jet stream ripping across the top at 60 miles an hour, turning the winds with height, and the rising column starts to spin. That's a supercell. That's the parent of a violent tornado. And Oklahoma builds them almost to spec. Because the last ingredient is the ground itself. There's no mountain range here to block the flow, no ocean nearby to calm it down. Just open plains giving the storms a clear, uninterrupted floor to organize on. The same flatness that makes the map look boring is the thing that lets the sky run wild. On May 31st, 2013, near El Reno, that machine produced a tornado 2.6 miles wide, the widest ever recorded in the United States, with winds measured near 300 miles an hour. It was so wide you couldn't see all the way across. It killed 8 people, including 3 veteran storm researchers who spent their careers chasing exactly this. So Oklahoma isn't random bad luck in the middle of the country. It's what happens when the wet half of America, the dry half of America, and a wide open floor are forced onto the same stage. The mild version of this climate never had a chance. And the oil fits the same logic. Those thick sedimentary basins that trap crude and gas were laid down by ancient seas across the same low, undramatic interior. The boring geology below and the violent geography above are 2 features of one flat central place. Now, I have to be straight with you, because if I'm not, the comments will do it for me. First, geography isn't the whole death toll. Forecasting has gotten dramatically better. Building codes, storm shelters, warning sirens, a whole chase and rescue culture. All of that shapes how many people a storm actually kills. The collision sets up the danger. What people do about it decides the rest. Second, and bigger, Tornado Alley may be moving. This appears to be a real phenomenon. Over the last decade, the worst tornado numbers have been shifting east, into Mississippi, Alabama, Illinois, the Mid-South. In several recent years, Oklahoma didn't even crack the national top 10. The classic Oklahoma, Kansas, Texas alley that everyone grew up with is getting argued over by the people who study it, and some of them think the center of gravity has already slid toward the southeast. And the oil. That's technology and law and capital as much as it is geology. Other places have basins and never built an industry on them. All fair, but here's what none of it erases. Where the alley drifts is ultimately a question about who sells the branded t-shirts. The mechanism underneath, though, Gulf moisture slamming into desert air over an open floor, doesn't become random just because its favorite address is changing. Move the pin east and you've moved to where that same collision now sets up most often. The physics of a collision zone travels. It doesn't disappear. And notice what the counter-argument accidentally proves. If the storms can pack up and shift a few hundred miles because the moisture line moved, then the storms were never really about Oklahoma, the place. They were about a boundary that happened to sit over Oklahoma, which is the whole point. Go back to that map, and the tidy, empty rectangle in the middle you'd skip right over. That emptiness was the tell the whole time. A place gets thin on people when the climate swings this hard and the economy booms and busts with the price of a barrel. High variance land doesn't fill up the way gentle land does. America keeps its extremes on the coasts, or so the coasts like to think. But some of the sharpest structure on the whole continent is sitting in the transition belt, right where the wet country and the dry country are forced to meet, and Oklahoma is standing on the seam. Oklahoma isn't the only boring state with a lot going on. If you want to see how a state with almost the same reputation ended up at the center of everything, watch the Ohio video next. The world has a structure. Let's keep finding it.